Hi, Assalamualaikum and good evening to everyone. I'm Hafiza Kazai from UiTM Pahang, Faculty Applied Sciences. And for today, I will share with all of you my lecture on CHM676 Organometallic Chemistry. Okay, I'm going to be covering two subtopics for this chapter 4. Compound with metal carbon sigma bond, and the second one is compound with multiple metal carbon bond. Okay, as you can see from the slide, the material are prepared by the LIC of the CHM676, who is Drs. Nur Shahidatul Akmal binti Muhammad Suhaimi, and I'm going to present it for my class. Compound with metal carbon sigma bond. Organic compound that are capable of making sigma bond with metal center are alkyl. Okay, example like methyl, benzene, methyl, ethyl, propyl. Okay, they are kind of example for alkyl group. The second organic compound is aryl. This one for benzene group, and the last one is acyl, which is they have carbon double bond or alkyl group. Okay, for the first organic compound that are capable of making sigma bond with metal center is metal alkyl. Okay, alkyl with no beta hydride such as methyl, benzene possibly can form stable complexes with transition metal. Okay, as you can see, I have highlighted the no beta hydride. Okay, where we can find the beta hydride. So, beta hydride actually attached to the carbon beta. So, where is carbon beta? Carbon beta located beside carbon alpha. Okay, as you can see from the figure structure, like methyl, okay, methyl structure, and another example is like neopentyl. They do not have hydrogen beta. Okay, so of course for methyl group, they don't have carbon beta, but for the neopentyl, they have carbon beta, but as you can see, the carbon beta, all the carbon beta attached to the carbon, not the hydrogen. So that's why they do not have a beta hydrogen. Okay, so this kind of structure can form stable complexes with transition metal. Okay, so instability of transition metal alkyl arise from the decomposition of the complex through beta hydride elimination, which is can form hydride olefin intermediate. So that's why to form stable complexes with transition metal, we have to choose alkyl with no beta hydride. Okay, as you can see from this mechanism, beta hydride elimination mechanism, if our organic compound or metal alkyl have beta hydride, hydrogen from the beta hydride have tendency to connect or to attach with our metal. Okay, so from that, the breaking of bonding make it that the olefin can be eliminated. Okay, whereas hydrogen remain bonded to the metal center. Okay, so after that, they can leave behind the metal hydride. So metal hydride can form unstable compound because they only have metal and hydrogen. Okay, therefore, alkyl with beta hydride tends to produce unstable complexes with transition metal. So, to form stable complexes, the first thing we have to find out the structure or organic compound that do not have beta hydride. Okay, and also to be made sure, they have two possibility that beta hydride elimination reaction can be occur. The first one is a vacant coordination site on the metal. So how to overcome this possibility is we use the bulky group. Okay, as example like neopentyl and trimethylsilymethyl to block all the attack from the surrounding, okay, coordination position. So this is, we call it as stabilizing by steric crowding. This is the first method how how to counterback the possibility for the beta hydride elimination reaction can be occur. And the second one is a vacant orbital on the metal to interact with beta carbon hydrogen bond. Okay, for this second possibility, because of metal we you choose is from only available in transition metal. So meaning that if our metal come from the main group metal, it is possible. Okay, it's possible to for beta hydride elimination can be occur, and also can produce stable main group alkyl. So meaning that for the second for the second reason, uh, it's only available in transition metal but not for the main group element. Okay, because of we can find the stable catalyst come from the they have the main group element, but also have beta hydride, can do the reaction with beta hydride. So which is there is a granite reagent. Okay, for the second is metal aryl. Okay, for metal aryl, complexes also tends to be stable. Okay, because they do not have beta hydride. But if the metal aryl have beta hydride on the aromatic ligand, so possibly to undergo beta elimination decomposition is not easy. Okay, because of they have these two uh, reason to achieve before they can undergo the beta elimination decomposition. Okay, the first one, in order for it to happen, the metal, carbon alpha, carbon beta and hydrogen beta have to all be coplanar. Okay, which is difficult to achieve because of the ring strain. As you know that benzene or aryl group, they have a resonance structure. Okay, to make sure that all these four kind to be all coplanar is very difficult to achieve. Okay, so although if they have can be achieved, this one will destroy the aromaticity, okay, which is not desirable and is compromised for the stability of the ring. Okay, so that's why it's so difficult to undergo beta elimination decomposition when related with meta aryl. Okay, so the most common aryl that can form complexes with metal are phenyl, okay, which is carbon 6H5. Okay, usually in the short form of PH, okay, represent of phenyl. Okay, so complexes such as these two kind of complex are stable and have been isolated. Okay, although they have beta hydride, the compound metal to sigma bond also can produce a stable compound. Okay, for metal aryl.